Hey everyone, welcome back to the channel. Today we're diving into the product rule. This rule lets us take derivatives of 2, 3, or more functions being multiplied. Don't worry, it's easier than it sounds, and by the end of this video you will be a pro. After we break it down, we'll jump into some examples and see how it works in practice. Let's get started. First, let's look at the product rule for two functions. When you multiply two functions, the derivative is the first function times the derivative of the second plus the second function times the derivative of the first. I like to remember it with this shortcut, 1d2 plus 2d1. Here, 1 is the first function, d2 is the derivative of the second function, 2 is the second function, and d1 is the derivative of the first function. This mnemonic has saved me countless times in my math courses. Honestly, I've probably used it on all my exams, especially for calculus, so I highly recommend learning it. Next, let's move to the product rule for three functions. When three functions are multiplied, the derivative is the derivative of the first function times the second and third functions, plus the derivative of the second function times the first and third functions, plus the derivative of the third function times the first and second functions. It sounds a little more complex, but don't worry, I have an easy trick to help you remember it. I call it d1k2 cycle prime through. What this means is start with the derivative of the first function, d1, and keep the other two functions, k2. Then cycle through the derivatives for all three functions. For each term, you move the prime to the next function in the sequence. You can see the prime in yellow being moved each term. You can apply this cycle the prime concept to taking the derivatives of 4 or more functions being multiplied. But for the sake of this video, we will stick to taking the derivatives of 2 or 3 functions being multiplied, which is all you need for your exams. Now, let's switch over to the iPad and dive into some examples. We'll work through them step by step, and by the end, you'll have the product rule down no problem. For our first example, we're asked to find the derivative of f of x equals x cubed times cosine of x. So we have a product of two functions, the first being x cubed, and the second being cosine of x. So we have to compute this derivative using the product rule. So let's do that. We have f prime of x is equal to, if we remember the shortcut 1d2 plus 2d1, that means we have our first function, x cubed, times the derivative of our second function, the derivative of cosine of x is negative sine of x, plus the second function, which is cosine of x, times the derivative of the first function, the derivative of x cubed by the power rule, is 3x squared. And if we combine everything to write this a little neater, we have f prime of x being equal to negative, put the negative from the negative sine x in the front, negative x cubed sine x plus, and let's put the 3x squared in the front, cosine of x. And that's our final answer. So for our second example, we're asked to find the derivative of f of x equals the square root of x times 3x minus 5. So again, we have the product of two functions, the first being the square root of x, and the second being 3x minus 5. And we can compute this derivative using the product rule, which I remember using 1d2 plus 2d1. So that means we have f prime of x equals the first function, which is the square root of x, times the derivative of the second function, which we can take the derivative of both terms and add them. So the derivative of 3x is 3, and the derivative of negative 5 is 0. 3 plus 0 is 3. So the derivative of the second function is just 3, and we add the second function, which is 3x minus 5, times the derivative of the first function. Now, the square root of x is such a common function that you should commit to memory the derivative. And the derivative of the square root of x is 1 divided by 2 times the square root of x. And let's just clean this up a little bit. So we have f prime of x is equal to 3 square root x plus 3x minus 5 divided by 2 root x. And that's the derivative of this function. Our third example asks us to find the derivative of g of x equals 3x plus 5 times the square root of x plus 4. Our first function is 3x plus 5, and it's being multiplied by our second function, square root of x plus 4. And to compute this derivative, we need the product rule, so 1d2 plus 2d1. So we have g prime of x is equal to the first function, 3x plus 5, times the derivative of the second function. The 4 is just going to be a constant, so we're going to ignore that. But the derivative of the square root of x, we just talked about, that's such an important function to know the derivative of that you should commit that one to memory. So that's just 1 divided by 2 square root of x. And we're going to add the second function, which is the square root of x plus 4 times the derivative of the first function, which is just 3 because the 5 is a constant. Derivative of 3x is 3. And when we combine everything together, we get g prime of x is equal to 3x plus 5 divided by 2 times the square root of x. And then if we distribute this 3 to both of these terms here, like this, we get plus 3 square root of x plus 12. And this is our final answer. For our fourth and final example, we're asked to find the derivative of f of x equals x squared times sine of x times ln of x. So we have three functions being multiplied, x squared being our first function, sine of x being our second function, and ln of x being our third function. And to compute this derivative, we're going to need the product rule for three functions, which we can remember using d1, k2, cycle prime through. So f prime of x is equal to the derivative of the first, which is 2x by the product rule. Now we keep the other two, so times sine of x times ln of x plus, and now the prime is going to cycle through to the second function, so now we take the derivative of sine of x, and we keep the first and third function, so let's keep that x squared, and the derivative of sine of x is cosine of x, and that's multiplied by ln of x. And then we'll add, so now the prime cycles through to the final function, which is ln of x. The derivative of ln of x is 1 over x, so let's write that down. And of course, we keep the first and second functions the same. So we have x squared times the sine of x times the derivative of ln of x, which is 1 over x. And we can't simplify the first and second term, but the third term has a little bit of simplification. We can cancel out one of these powers here. So this can be to the power of 1, and this whole term over here will cancel to 1 as well. So we can write our final solution as f prime of x is equal to 2x times the sine of x times ln of x plus x squared times cosine of x times ln of x plus x sine of x. And this is our final answer. And that's it, everybody. I showed you how to calculate the derivative of 2 and 3 functions using the product rule and work through 4 examples step by step to show you how it works in practice. I hope you enjoyed this video. If you did, please leave a like and share it with someone you think could learn from it. Consider watching another one of my videos to continue learning. Let me know in the comments if you have a problem or concept you would like to see covered, and subscribe for more math and educational content. Have a great day, everyone.